Okay, welcome to section 6.2. In this section we're going to talk about multiplying and dividing rational expressions. And that's pretty much it. So let's jump into it. We're not going to forget about non-permissible values. We're still going to deal with these, but we're going to start with multiplication. Now here is a nice little slide here that's going to compare multiplying with fractions, okay, expressed in rational numbers. That would be this one, and variables. Okay, same procedure. Basically, you multiply across numerators to numerators, denominators to denominators. So you kind of treat it like two separate questions. 5 times 4 is 20. 8 times 15 is 120. Then you divide them and you get 1 over 6. And with variables, it's the same thing. Important variables, just like in numbers, common factors will cancel. So for instance, in this question down here, you can see that x squared cancels, and y cancels, leaving you just y to the 1 at the end. Okay. The non-permissible values, however, is you're going to take a look at basically the first step. Okay, when first or second step, as long as you haven't canceled anything out yet, that's when you're going to take a look at it. Okay, so here we go. So here's the first question that was in your notes. Longer question, and something that I'm not going to go through this. Obviously, you can read it on your own. Hopefully, it makes sense to you. But it's very important, almost critically important at this stage, that you factor first before you multiply polynomials. Because if you don't, you're going to end up with cubic, quartic, or higher order polynomials. For instance, if you multiply this, you're going to get 8 to the 4. You're going to get a quartic polynomial. Well, we don't have the tools yet. You guys don't have the tools yet to factor that. Okay? Once you do, then you could go ahead and do that. But the better or cleaner way at all times is to factor first. Okay? So, let's do these two examples right here. So, express each product in simplest form. What are the non-permissible values? Okay. So, here we go. So first off, you can already tell me what the non-permissible values are. You really can set these guys equal to 0 separately. You don't have to do them together. So here, if r was 0, then everything would be 0. Okay? Because if this was 0, if that term was 0, then when you multiply by anything, it becomes 0. Okay? Same with d minus 2 equals 0, that means d equals 2. So together they basically mean r can't be 0 and d can't be 2. Okay, those are your non-permissible values. Okay, so now that we're done with that, we can start canceling things. Right off the start, okay, you have to rewrite this. Then, oh geez. Right away we can actually cancel 2 pi r, leaving you with d times h over d minus 2. That appears to be the simplified expression. Can't go further than that. For b, okay, so that's it. I mean, for b, we're going to treat these separately again. We might as well. You can almost do this by inspection. If you have r cubed minus r equals 0. Okay, you know r equals 0 is going to be one of the factors, but also r equals 1. Okay, to show this, we could factor out an r, so r can't be 0. And we actually can factor this further, because this is a difference of squares. Gotta be careful, right? So r equals plus or minus 1. Okay, so therefore r cannot be 0. And let's do this in order of smallest. Whoa. smallest to largest. Why does it do that? OneNote, why do you do this to me sometimes? Hopefully you can still see everything. Okay. So -1, 0, and 1. Okay? And on the other side, we have y plus 3 equals 0. So y cannot be -3. So there you have it, your non-permissible values. Right there. Okay? So now we can go ahead and multiply. Now, like I said in my previous slide, I would suggest factoring everything first. So the top of the left-hand fraction becomes the following, and the bottom becomes the following. And I'm going to use square brackets. Don't be intimidated by them. I don't like to use round brackets twice in a row. Gets a bit convoluted. And you know what? I'm just going to rewrite this thing. Oh man, it's this eraser function. Apparently it thinks it's a... Apparently it thinks it's some kind of... what the heck? You know, Microsoft needs to get it together here. Or maybe I just don't know what the heck I'm doing. One of the two. Okay, here we go. This is r plus 1. This is r minus 1. Right? We already factored it over here. So, we have this canceling off. We have y plus 3 canceling off, which is great. And at this point, you're probably saying, why didn't you just get the non-permissible values from this step right here? Totally cool. That would have been a good time to do it, because you have r, so that's 0, r plus 1, so that's -1, r minus 1, so that's plus 1, and 1 plus 3, so that's minus 3. That's all your non-permissible values. There you go. So, when you move on, you have y minus 3 times r. Now we're multiplying across. R plus 1. And you know, I forgot to cancel r's up to the top, so we'll just cancel them here, okay, because they cancel out. So you're left with now y minus 3, r plus 1. Okay, and there you have it. Just like that. Okay? So that's basically multiplication. Moving to division, we're going to turn it into multiplication. So basically all you're going to do is multiply rational expressions. Division is, the strategy is to multiply by the reciprocal. So let's take a look at a numbers example right here. If you go 5 divided by 3, 5 over 3 divided by 1 over 6, this is the same thing as multiplying by the reciprocal. 5 over 3 times 6 over 1. Okay. Which is obviously a pretty easy procedure, actually. You just have to remember to do this. So with variables, it's the same thing. So when you look at the variables example, 3x squared over y squared divided by x over y is equal to 3x squared over y squared times y over x. Then you can go canceling things. Take a look at this step to get the non-permissible values though. Okay? Because here x cancels from the denominator eventually. So do not ever look at, okay, that step, the last step for the non-permissible values. So you can take a look at the examples and look at these. Look at the work. Let's do this one. Simplify and what are the non-permissible values? Okay, so right away you can go ahead and rewrite this as multiplication. And I really hate using this notation. In fact, I'm going to erase it and try not to scroll down when I erase it. I hate that little x notation because it looks like an x. I prefer brackets. There we go. That's just because my writing's bad. Okay, so to multiply this across, I'm going to factor first, then get the non-permissible values, then simplify. So here we go. Let's factor the top here. We're going to get C, poor choice of variable to use here, and we're going to factors of 7, that makes 6, well 7 and 1, minus 7 plus 1, game over there. This is all over C minus 7, C plus 7, game over there. Here we're going to factor out a C to get C plus 7, coincidence, and then we're going to have C, and we're going to have 7, 1 again. Easy. So the non-permissible values, which I'll start doing them in blue, are, look at the bottoms. Look at the bottoms here. So clearly C cannot be 7 or minus 7 or 1. So it can't be negative 1. Sorry, negative 1. Can't be negative. Let's put negative 7 first, negative 1, and then positive 7. Okay, can't be any of those guys. And that appears to be it. Now we can start canceling like crazy. C plus 1 will go, C plus 7 will go, C minus 7 will go, and that looks like it. So here we're going to have C over C. Oh, for crying out loud. Oh, geez, this thing is just infuriating. We're going to have C over C plus 7. Okay? Pretty straightforward. The last question will combine them. Okay, we'll combine multiplication and division. So there's really nothing new here. You just got to go slowly and try not to make any mistakes. Okay, so you can see how this might be a long procedure. Don't be intimidated. Okay, when you go step by step, as long as you in your brain know exactly where you're at, okay, who cares how many steps it takes? The more factors, by the way, that you have that are unique, okay, certainly the more non-permissible values you'll have, as you can see at the bottom of this question. So let's do it. Here we go. Finish off this section. Simplify and define all non-permissible values. So we have 3x plus 12 over this polynomial on the bottom divided by 12 over another polynomial, all times by some other rational expression. So the first thing I'm going to do is I'm going to rewrite this. Okay, I'm going to rewrite as a reciprocal, and I'm going to multiply. Okay, so now if you want to save time, we could factor at the same time. So maybe I'll say that factor as well. Okay, that's what you're going to end up doing anyways eventually. But I think we can make this jump, hey? We can make this jump. So here we're going to factor this guy. Hopefully I can do this using the old, oops. Oh, here we go. Here comes the eraser out again. I never used to do this. This must be some kind of new mistake. Okay, so here we go. Factors of 12. Probably going to be 4 and 3. And the 3 is probably going to go here. 4 is going to go here. So we get 9. Yeah, that's correct, I think. As long as that's a minus and that's a plus. Let's see if that gives it to us. 9 plus 4. Yeah, that's right. Perfect. Now we're going to multiply. And this is going to look kind of ugly. But here comes a big square bracket. And we're going to have multiplied by 3x plus 4 over 12. Hey, isn't that convenient? 3x plus 4, 3x plus 4. Awesome. And now, this one, we don't do the reciprocal because this is great. This is great. That's a multiplication. So we're just gonna get this out of here. So as you can see, this is going to turn out really well. Here's where you do the non-permissible values. Okay. Okay, find non-permissible. I never can spell this word. Permissible. I think it's right. Values. Here. Okay, and you just look across, and clearly x cannot be, and this is gonna be in any order here. So I'm just gonna go across. Can't be -4/3. Can't be 3. Can't be -4. Okay, 12 has nothing to do with anything with x. Those are the non-permissible values. Okay, you can order them from smallest to largest, but whatever. You get the idea. Here we go. Time to cancel off like a madman. 3x plus 4 cancels, x plus 4 cancels, x minus 3 cancels, and we're left with not much. Okay, so it's actually, this is all the x values canceled. So we're going to be left with 6/12, which is 1/2. Jeez. So everything reduces. That worked out well. And that's it. Okay, so so trust me, if you just follow the steps, you can't go wrong here. You just have to go slowly, and you'll be fine. So work in the practice problems. Very important you work in the practice problems, and then when you're ready, you move on to the next section, section 6.3.